record on this computer. Very good. Okay. Welcome everybody to another Shocklab seminar. We're extremely happy to have Sasha coming to talk to us, who has connections both with UCT, where he studied his master's in evolutionary computation. Is that correct?
Yeah.
Yep. Was that with Jeff?
Yeah, it was with Jeff.
Okay. Fantastic. And now with InstaDeep, and of course, InstaDeep had lots of connections with Shocklab now. So yeah, we're extremely interested to hear your take on the Python versus Julia competition. Over to you.
Awesome. Thanks so much for the intro, Jonathan. Yeah, lovely to be here. Yeah, this is basically kind of looking beyond Python and talking about why you should maybe consider Julia for your next RL project. And I think it's especially applicable for people in research, because I feel like that's kind of where the Julia language is aimed. Yeah. So who am I? Why am I giving you this talk? So like Jonathan said, I did my master's at UCT. I used PyTorch initially, and it just wasn't fast enough for what I wanted to do. So I kind of had a look around at the options and chose Julia and really kind of fell in love with the language. And in like 2 weeks, my whole master's was in Julia and like 100 times faster, which was, great. Now I'm at InstaDeep. I still kind of code in Julia as like a hobby and have a side project in Julia that at the moment I haven't touched in about a month, but I'm relatively active on it. And then mostly code in JAX, which if you are in Shocklab, I'm sure you've heard Run and Claude talk about. It's kind of this new deep learning library in Python. So yeah, I think I'm kind of uniquely positioned here as someone who's had quite a lot of experience with both Python libraries and Julia, to give you a perspective on why I'd recommend Julia. So yeah, just to start off, what is Julia? It's a language that was made to kind of replace MATLAB, which is a numerical computing language, and as such, it's very kind of related to scientific applications. And so they built a really awesome language and started building really great kind of scientific and numerical computing tools. And in doing so, they've also built a really good language for doing AI in. So yeah, that's the logo. So just like a very quick rundown. If you ever code in Julia, this is what you'll see. So very similar to Python syntax, for loop, if, prints, all very similar, indexing arrays, very similar. Yeah, it's got the little ends to close the for and the if, but otherwise pretty much the same. The really nice thing, or one of the really nice things, is that it's got NumPy-like array manipulations built in. So it's first class. You get you can index matrices, you can slice them, to get vectors, to get arrays, whatever. You can generate random matrices. If you saw on the previous slide, you can generate like a matrix or a list of ones, and that's all just built in. You don't need a special library for that. It's also got first-class support for notebooks, which if you guys are data scientists, I'm sure you use quite often. Jupyter actually stands for Julia, Py, Python, and R. So it's first-class support. This is actually a really cool notebook, like application software, I guess, written in Julia. It's called Pluto, and it's like super reactive and has some cool perks. Yeah. So that's a very basic rundown of what Julia is. I don't really have enough time in this talk to give you a full rundown of Julia, but that's just very basically, it's very similar to Python. Yeah, with some nice built-in numerical computing stuff. But like, why is it cool? What really sets it apart from Python? So just got 3 short examples here, and there are a lot of reasons, but these are the first 3. And this is not specific to AI. This is just why is Julia cool as a language. So first is macros. Macros are things that read your like code code's text at compile time and then change it at runtime. So basically the first one, at show, so macros in Julia are denoted with an at symbol. At show is really, really useful for debugging. And basically what it does is it'll turn that f of x plus y, it'll turn it into actually printing out f of x plus y equals and then the result. So super useful for debugging. The at threads macro is amazingly, like it's built into the language, and it's just super easy to parallelize things, especially embarrassingly parallel things. So this is just parallelizing the for loop, really useful. And then the last one, at b time, it's just for benchmarking. It'll run the function multiple times, it'll do some statistical tests, and it'll tell you how fast your function is. Yeah. Just before I go on, I forgot to say, if anyone wants to interact, please feel free if you've got any questions. I'm more than happy to take them in the middle of the talk. Anyway, next thing, this one's a little more subtle. It's explicit broadcasting. So NumPy and PyTorch and TensorFlow and all those have implicit broadcasting. And that's really nice, but you often don't realize that it's happening. And so it's really easy to run into bugs with this. So kind of a simple example is you could have an array of shape 1 by 5 and then a vector of just, length 5. And you could multiply those, and you could expect that those would multiply element-wise, because they've just both got 5 elements, and the one's got a singleton dimension. But actually what you'll get is a matrix of 5 by 5 if you do that multiply. And then further down the line, you might mean that whole matrix to get a single number, and that kind of process will be lost. You won't even see that the error is there. It's like a very sneaky, silent way that this implicit broadcasting can hurt you. In Julia, that will actually be an error, which is really nice. So when you know that, hey, I'm doing broadcasting here, or rather I should do broadcasting here. And the way that you do broadcasting in Julia is with a dot. So if you look at the top example, if you try to add 1 to that list or vector, it gives you an error, but if you go dot plus 1, it works. And so this actually extends even further into a really cool feature where you can apply that dot operator to functions that you write. So it doesn't have to be like built-in functions. So I've just got a very simple function, f of x plus 1, and I've applied it, it takes in it expects a single scalar value, but I've applied it to a whole list with the dots, so f dots of your list, which is super powerful, and that f could have been, arbitrarily complex. So you can really write your code for kind of the single case rather than writing it for arrays. And this is actually something that Jax has brought in, and one of the reasons why it's quite popular with its VMAP. Anyway, the last one is something that I would be remiss if I didn't mention. It's something that I wish I had more time to go into. It's Julia's multiple dispatch, which is such a ridiculously powerful feature that pretty much no languages have. I think there's like a list of maybe 10 languages that have it, and most of them are not very popular. So what this is function overloading on steroids. It's like super powerful function overloading. It's hard to give an example, but this is the basic idea. In kind of your standard object-oriented language, you could like subclass some superclass, and you could overload the function and get it to work on a different type. But that only works on the first argument of the function, and it also only works on the runtime type of the argument. Sorry, the compile time type of the argument, not the runtime type. Julia, you can actually do it for like an arbitrary number of arguments. So you can have like 20 different methods if you've got 20 types, and a list of like 5 arguments. You can have them all be different types and write different methods for them. And at runtime, it'll pick the best one to execute. And this is like absurdly powerful for when you're creating large systems. Yeah, if I had more time, I would go into it. And yeah, if you want to know more, feel free to ask a question at the end. Yeah. So really, what's like the problem with Python? It's ubiquitous, it's everywhere. If you've done AI for 10 minutes, you've heard of Python and probably seen some AI code in it. So there's two really big problems with Python. Number one is the two-language problem. So in Python, pretty much all high-performance code is written in some other language, either C, C++, or Fortran, something low-level, something that's compiled and really fast. And while that's great, that gives you really fast code. There's a big issue with that, which is, let's say you are debugging or you're trying to find out what a method does, and you're kind of stepping into methods. Eventually, you're just going to hit this wall where you're like, okay, I can't go any further because now I'm looking at I'm kind of hitting the like C and Python barrier. So you've got two choices then. You either go onto GitHub, hope that C library is public, and then you have to find that method that it's calling, and then you have to read C code, which sucks. Or you just kind of give up and accept that your bug isn't there, or the method does what you expect it to do. Both of which kind of, yeah.
Can I just ask a quick question there? For this particular type of problem, how good at the moment is ChatGPT when you want to ask that question?
It's a good question. I haven't tried that. It probably would give you a really good answer. Yeah. I guess you could say, hey, I'm hitting this wall. This is the name of the C method. What does it do?
Yep.
Yeah.
Cool.
Yeah. Cool. Yeah, so that's the one really big problem. The other big problem that ChatGPT definitely can't solve is that Python is just slow. It's an interpreter language. It's slow. It's great and it has its massive benefits, but yeah, it is quite slow. So yeah, we get it. Python's slow. Is Julia actually faster? Is it worth it? Yeah. So in short, yes, it's a lot faster. To explain this graph, it's a little complicated. All the dots are different benchmarking tasks and how long they take. But it's not quite how long they take, it's how long they take relative to a C implementation. So that like first single dot on the left is C, and then the second column is Julia. And so you can see that all the Julia kind of benchmarking tasks are within one order of magnitude of C speed. So it's really fast. You're pretty much writing C speed code, but you don't have to do memory management. Like Julia's got a garbage collector and it's looks very Pythonic. And then Python is the third last column. So it's all kind of 1 to 2 orders of magnitude slower than C and also slower than Julia. Yeah. So isn't JAX fast? Maybe you've heard of this thing called JAX. It's a Python library, so you technically still be in Python, but you'd also have the benefit of speed because JAX is fast, and you'd be totally right. But there's some reasons why you might not want to consider JAX. So yeah, what is JAX? Basically, it's NumPy plus just-in-time compilation plus autograd, so auto differentiation. And yeah, it's nice. It enforces some really strict kind of rules, and it works in like this subset of Python. But at a high level, it's basically just NumPy. So that kind of means that it's basically just a slightly lower level PyTorch or TensorFlow. Yeah. So this is kind of one of the reasons why you might not want to consider JAX. I'll give you guys a couple seconds, but if any of you can tell me what this code does, I'd be really impressed. I'll give you a hint. It's actually really simple. Yeah. But see, I see you're here. You're not allowed to comment because you were at the Indaba, and you know the answer. Yeah, and no takers. Cool. It's looping through a list and checking if the element is even, and then printing out that element. So that's a really simple thing to do, and it's taken this much code in JAX. So JAX. Don't get me wrong, JAX is insanely fast, but code complexity is a tough one in JAX. Another thing is that JAX is a domain-specific language, so that comes with a couple drawbacks. Firstly, there's the cost of learning a whole new language. So you do have Python and you do have its niceties, but there's a lot of stuff you have to learn just to jump into JAX. It's got limited applicability because you wouldn't take JAX and then apply it to building some application. You're really gonna use it for AI. There's a lot of kind of similar, but none of them are really standard domain-specific languages. So like TensorFlow, DSL, PyTorch, XGBoost, so the list goes on. And yeah, so that makes it harder to find code examples because now you've got like 4 different competing frameworks, and yeah, so there's issues with that. And finally, probably the biggest issue with JAX is that it requires static sizing. So you have to know the size of your array at runtime, at compile time, not at runtime, which is often really tough, especially when you're writing an RL environment. Sometimes you kind of just need some sort of dynamism, and so that makes it super difficult. But if you can keep it static, then it compiles your code once and it makes it super fast. So yeah, back to Julia. I've told you guys that it's fast. It's faster than Python, and there's some issues with JAX, which is the thing that makes Python fast. But I haven't actually shown you that Julia can do AI stuff. So yes, it can. The kind of base of any AI framework is autograd or auto differentiation. It's just something that if you give it a function, it'll differentiate it. And Julia has a wealth of these. So it's got zygote, forward diff, it's also got reverse diff, it's got this new thing called enzyme, and it's got diffractor. Some of these are kind of work in progress, some of these are very stable, but it's got a wealth of autograd. And the absolutely amazing thing about Julia's autograd is that all of them work on Julia arrays. You don't have to have like a JAX ND array or a torch tensor or a TensorFlow tensor. It just works on like a pure array. So if you have a function that takes in an array and outputs a scalar, you can take the gradient of that function, which is amazing. The really cool part about that is you could take some other library that does some random computation that was never meant to be derived, and take the derivative of it because it just works, because you don't have to somehow wrap the stuff that you're passing in tensors and hope that the function in that library keeps it in a tensor so that you can track the gradient, so that you can take the overall gradient. It just works, which is insane. And in fact, the last 2, enzyme and diffractor, are quite like moonshot kind of projects, which actually are aiming to differentiate LLVM code. LLVM is like an intermediate representation, so almost binary, and they're trying to differentiate that. So it would even give you differentiable like C and C++ code, which is quite cool. But honestly,
can I just ask another question there? So does that mean that you could take some sort of gradient-free optimization problem and turn it into a gradient-based optimization naturally with this?
Yeah. If the function outputted a scalar, I think that's the only kind
So you
that's
could
only constraint.
so you could do like genetic algorithms using gradients.
Yeah, I guess you could. I guess it depends where you want to take the gradient in the genetic algorithm. But
Sure.
yeah, there isn't a reason. As long as you can have that process running and have it output some value, some fitness, then yeah, you can take the gradient of that. It'll just work, which is yeah,
cool.
quite cool. But yeah, mostly you won't be interacting with these autograds because you usually don't even interact with them in Python. You have like one function called gradient, and that's kind of all you do with them. And so what you'll mostly be using is like the front end of these, which is Flux in Julia. So Flux is very PyTorch-like. It's got, everything you'd want. It's got like chain or sequence. It's got dense layers. It's got convolutional layers. It's got transformers, whatever. It's all really simple, and it's all written in Julia. So when you want to click into this function and see, how does this work, it's Julia, and it's all readable because it's not C and memory management and all that kind of stuff going on there. Yeah, that was this point. It's all Julia. Another kind of adjacent but kind of similar ecosystem is, so that was kind of the ML ecosystem, and this is the SciML ecosystem, and I think it's especially relevant to everyone in the maths department. It's the differential equation packages that Julia offers are like unparalleled. I haven't done any differential equations, but from what I've heard, they're very easy to use and very nice. And you don't have to use kind of old Fortran libraries, which is quite cool. So yeah, the question then becomes, cool, I've told you that Julia is fast, it's simple, it's got AI tools, but do you have to learn a whole new language now? Yes, you do, but your kind of learning time is not too bad. So, the top line is Python, really easy to learn. Everyone knows that. Julia's got, a few extra quirks. It's got some cool things you can do with like its optional types, and that multiple dispatch thing that I mentioned earlier is a little bit of a learning curve if you want to use that. But really, there's nothing like, there's no kind of rules that take it too far from Python land. Jax, on the other hand, someone who's been using it for a year and a half now, and I don't feel like I know it very well. It's super difficult. Anyway, here's a concrete example. The same example with the Jax code earlier. So here's this, you're making a list, you're looping through it, you're checking that it's divisible by each element is divisible by 2, and then you're printing that. In Julia, it's pretty much the same thing. There's some nice list syntax, or range syntax, I guess, with a 0:4. And they've got the end at the end, but otherwise it's pretty much exactly the same. And then you've got this mess, which is Jax, which is the thing that makes Python fast. I think it's pretty clear to see which is easier. But it's not all sunshine and roses. There are things about Julia that are not great, for sure. So the first one is array start at 1. As a computer scientist, this hurts my soul. But Julia was built to replace MATLAB like originally, and that's just a kind of artifact of that. And I think it actually works rather well for scientific computing. Just the kind of things that you do, indexing at 1 is surprisingly kind of non-consequential. It doesn't really get in the way, and after a week of using the language, you kind of forget it's there. But it is something to know. And then this, in Python, there is a C library or a Python library for anything. Like absolutely anything you could want to do, Python has a library for it. In Julia is definitely a newer language. It was made in, I think, 2012, whereas Python's like the 1980s or 90s, I think. And so, you know, there's a couple decades more of infrastructure in Python. Personally, I haven't run into any like any library that I wished was there that, you know, didn't exist. But there's absolutely, you know, a much higher chance with Julia that you'll run into that, where you're like, oh, this just exists in Python, but it's not here in Julia. The cool thing is, though, that Julia has like first-class support for calling Python. Well, not first class, but like very good support for calling Python. So you can see here, I just have to, using PyCall, which is like Python's import, and then I can go NumPy as PyImport NumPy, and I've got NumPy. And in fact, the things that are returned are just regular Julia arrays, Julia types, which is awesome. This is actually used really heavily in Julia's reinforcement learning library, which I'll get to in a sec. But it's used for importing gem, importing Majoku, like it all just kind of works, which is really nice. Yeah, so before I get to reinforcement learning quite yet, or the reinforcement libraries in Julia, let's just go over how fast Julia is one more time. So some of you might have seen this tweet and this library blew up a while ago. It's pure JAX-RL. So what they did here was really quite impressive. It was honestly insane. They basically took the whole RL algorithm, including the environment, and put it on the GPU. So you never interact with the CPU at all. All environment interactions are GPU-based. All updates for the networks are GPU-based, you know, everything. And it got insane speed. So I did a little kind of quick experiment. In green is cleanRL. So cleanRL is just regular Python. I think it was the PyTorch one. And yeah, that took about 2 minutes to solve carpol. Then in orange was pure JAX-RL, so the one I just spoke about. And that took, I think it was like 5 to 10 seconds to solve carpol. And then in blue is a little PPO that I wrote in Julia. These were all PPO, by the way. And yeah, that took like, I think it was 10 to 15 seconds. So very, very close to the JAX speeds. Yeah, one thing that I will say, this was all done on the CPU. If you put it on a GPU, JAX would probably have run away a little further with it. That being said, it is possible to do what they did with pure JAX-RL in Julia. It's just harder. Yeah, that's one of JAX's strengths, which I'll get to in a bit. So yeah, what exists? Like, you want to do your next RL project in Julia. What exists now? So the first one is AlphaZero.jl. So AlphaZero, for those of you that don't know, was that algorithm that beat the best Go player and became the best chess engine and all that stuff. Blew up in, I think it was 2018. And this library kind of epitomizes my point of why you would want to do anything in Julia. So there's two kind of types of AlphaZero libraries right now. One of them is written in Python and impossibly slow, because in AlphaZero you have a whole tree search which you have to do, which if you write that in Python, it just is too slow. Or it's written in C++, and then it's just really hard to read because you're doing machine learning in C++. And so, yeah, this kind of comes in as a really nice middle ground. And you've got just all of AlphaZero, including the tree search and the other parts, the kind of backprop and gradient, written in Julia. Then you've got reinforcement learning.jl, which is basically like your stable baselines, or I'm forgetting the name, RLlib, or one of those at the moment. And this actually has quite a wealth of support for different things you might want to do in RL. So it's got quite a bit of multi-agent RL stuff. It's got some offline RL stuff. It's got some planning stuff. There's quite a lot that they've covered in this library, which is actually really impressive, because it's completely open source. I think it's maintained by some students at a university, or rather a professor at a university, and it gets passed down to kind of different students. But yeah, it's quite an impressive library. Then we've got this cleanrl.jl. This is my side project that I mentioned earlier, and it's what I used in that benchmark. And yeah, I find that in Python, the cleanrl way, where it's like a single file, is a really nice way to do research. So if any of you want to do research, there is some nice starting point for you here. Yeah, so kind of sort of wrapping up, what kind of person should consider Julia? When is it kind of better for you to use it? So I would say if you're in industry and you're doing RL, probably not. Just because the language is still not quite mature enough. Like I mentioned earlier, if you're in industry, there almost certainly will be times where if you had Python, or if you were using Python, you would have just been able to like import some library and call a method on that library. And in Julia, you would have to write your own, it'll happen at some point. And so that's why I think it's just not quite ready for industry. But for research, where I think that's less of a concern, because you're often just doing novel stuff anyway. And most of what you need will be there, if not all. I think it's a lot more applicable. Yeah. If you have access to any TPUs, or possibly even a large amount of GPUs that you want to use simultaneously, it's probably going to be easier to work with PyTorch or JAX or one of those. For TPUs especially, just go with JAX. That's not even a question. But if you've got kind of like 5 GPUs and you want to use them all at the same time to do, something where you need a huge amount of VRAM, yeah, then you go with, then you'd want to go with something that was a bit more established. Because I think while Julia is easier in general than JAX, and I wouldn't necessarily say it's easier than PyTorch, but while it's kind of on par with PyTorch, I think those libraries have the backing of Google and Facebook and all that kind of thing, and their use case really for these libraries often is large language models, where you need huge compute and you need it to work across like cluster nodes and multiple GPUs. And so if you have that use case, that is definitely more mature in Python world. But if not, if you want a single GPU, and you have normal sized experiments, I think Julia is definitely very applicable. This one's quite specific to RL, but if you have an environment that you just can't write in a static way for whatever reason, and there could be many, but you just have to have some sort of dynamism in your environment, then you can't consider JAX. And if you considered kind of PyTorch or the like, you'd be giving up on a lot of speed, right? And so then that's where then Julia makes a lot of sense, because it's pretty much as fast as JAX, but it gives you more leeway in what types of code you can write. Yeah, and yeah, that's kind of it. I think I think Julia is pretty cool. And yeah, I welcome any questions.
Awesome. Thank you very much. That was great. This is another question directly about Julia. Do you know Henri Laurie by any chance?
I don't know.
Okay.
But is he the applied maths professor?
Yeah, exactly. Yeah. Who
I haven't heard.
Has been a Julia proponent for many years actually. Yeah, was trying to get me into it several years ago. Unfortunately, I've been doing Mathematica for a little over 20 years now, so I'm it's a little too ingrained. But I'm very happy if my students want to take this path.
Awesome. Yeah, no, that's fair. I think once you find something that you like and you're good at, it's hard to change.
Yep. Cool. Are there any questions?
I have a question regarding the comparisons of speed. There's something to say about the strictness of JAX, because once your implementation is correct, you're guaranteed amazing performance. Julia, on the other hand, allows you leeway with how you implement things. And that means that you can implement them in non-ideal ways and not realize it because it will still work. So how much of this performance is with assumed ideal implementation in Julia?
That's a good question. So are you talking about the graph with the dots?
Yes, exactly.
Yeah. I think that is all assumed ideal implementation. And that's a great point. That is, the benefit of being strict, where it kind of forces you to do these things correctly. And at the price of maybe your sanity sometimes when you're writing code. Yeah, in Julia, you can write things kind of incorrectly, I guess. Although I will say that there have been quite a lot of really cool tools that have come out recently that help you with type instability, which is a large cause of slowdown in Julia, and the like. But yes, you're absolutely right. If you get it working in JAX, you're pretty much guaranteed that it'll be super fast.
Okay, and in terms of like the people using this, I know it's mostly researchers and sort of open source community. Do you ever see this becoming used in industry? Is there a cold start problem where everyone's moving towards JAX? Because even for someone that's in academia and maybe in 5 years' time, is going to be working at some company, would it not be better to just invest that time in the meantime trying to learn JAX, even if the CPU takes longer initially? Yeah, like what are your thoughts there in general?
That's a great question. So one place that I do see Julia being used a lot is actually in climate modeling. It seems like there's a couple massive climate modeling efforts that are currently using Julia. I can't think of a name off the top of my head, but I can find that for you if you want. But on your other question, do I see it being used? Well, actually, let me carry on that question. Do I see it being used in industry anywhere else? Probably not for a while. And reason being is because I think I mentioned this a little bit. PyTorch and JAX and TensorFlow have the backing of massive companies like Google and Meta and the like. And so they have just so many more people that they can pay to work on these projects. Whereas Julia, pretty much everything is open source. There's one or two projects that are open source, but paid, they have paid workers, but the majority of the Julia ecosystem is open source. And so would I recommend? Yes, I would. I think that Julia can teach you a lot about coding in general, and it's not so dissimilar from the other options out there that I think you'd be losing out if you chose to write your code in Julia. Yeah, I think it's a really good option, and it's I guess you could be hedging your bets a little. There is definitely the possibility that I'm wrong and that it gets picked up. There's also the possibility that you invest your time in JAX, and then this new thing called Mojo comes out, and that's the new big library. And so then you've wasted your time with JAX. Yeah, I also see that Julia is more kind of widely applicable than just learning an AI library. So like I mentioned, a lot of AI libraries are domain-specific languages, and so you wouldn't use them for much else, but Julia you could, if you wanted to use it for web design, there are libraries. There's a lot of like visualization that you can do in Julia that's really nice. That sort of stuff. Yeah.
On that as well, on performance, a lot of times people compare like Julia, Python. I mean, I know that Julia is much nicer to write in the sense that you don't have to import these libraries and have different sort of ways of typing things. But to be fair, you could also just import something like Python, where you could compile the Python code you've written and run much faster, even though that'd be probably running on CPU instead of GPU. But just in general, for comparison of speed, how do you find something like compiled Python as opposed to Julia for maybe not only AI applications, more in general as using the language?
That's a great question and not one that I can answer because I've actually never used Python. I think I used Number once, but yeah, the only experience with compiled Python that I have is JAX. From my understanding, a couple of the compiled Python implementations restrict you to like a slight subset of Python. But yeah, I don't really know enough to comment on that. Sorry.
A slightly different sort of direction, but how quickly is the community growing in Julia compared to, say, Python or JAX?
So community is growing pretty fast. There was actually, I think about a month ago, there was a JuliaCon, and they always do kind of a state of Julia thing. And it includes like just general stats about how people like the language and what they like about it, but then also just how it's growing. And they are seeing kind of constant year-on-year growth, which is great. Yeah, they're nowhere close to the popularity of Python, obviously, because it's pretty ubiquitous. Yeah, I don't know about the growth of JAX. That's a great question. I have no numbers on that. But one thing that I will say is that Stack Overflow often does those like developer surveys of like, ooh, how much do I like this language, which is my favorite language, which is honestly, they're a bit of nonsense, but pretty consistently Julia is top 5. So people do really, the people that get into Julia do really enjoy it, even if the amount of people there is not quite as much as Python.
Cool. Any other questions? Oh, yes, Injin.
Sort of comment, not really a question, but yeah, I did Henri Laurie's courses in first year, and he made us use Julia to do some of the projects. But interestingly enough, yeah, we did lots of differential equations for chaos 1043. I know, Jonathan, I think you teach that course now, so just a comment on that. Yeah, it's amazing for chaos, especially where you can simply implement these things, especially like population, predator-prey models, and that sort of stuff. Yeah, it's like a couple lines.
Nice.
Awesome.
Cool. Any other questions from anybody? Myron, are you sold?
I am.
Just like that?
Sorry,
Wow.
I'm 100% sold. I was a bit worried about having to learn an entire new language, but the code is so similar, and just the speed difference is just crazy. So I'll definitely be looking into this before I look into JAX. JAX looks like a lot to get into, but Julia seems very easy, just coming from a Python background.
Yeah.
Cool.
I would agree.
+1 there. Good work. Great. Wonderful. So thank you very much again, Sasha, for a really interesting talk. Yeah, I think it will certainly get some of these students thinking. I'll post the video to the Slack channel, and you can let us know offline if you're okay for it to be uploaded to YouTube. But there's no pressure there. But yeah, wonderful. Thank you very much again, and hope to catch up with you properly soon.
Awesome. Thanks for having me. It was really fun.
Thanks, everyone.
Cheers.
Bye-bye.
Cheers.
Cheers.